Hello everyone, in this video I'm going to show you how to set up a Aurora Postgres instance in the console, and I'm going to walk you through step by step and explain to you what each of the settings mean, and then at the end I'm going to show you how to connect to your instance using pgAdmin, which is a popular dashboard tool where you can kind of view all your databases, make tables, and do any other administrative tasks. So let's just jump right into it. In order to get to the RDS section of the console, we need to either click on RDS here if it's in your recently visited services, or you can go to the top and just type in RDS and it'll bring up the RDS option. We're just going to click on this guy and it'll load the console for us. So let's just give that a moment here. All right, so this is the default section of the RDS console. So in order to create our Aurora database, what we want to do is go to the left-hand side here where it says databases and just click on that guy. So this is the page where if you had an existing database that already existed, you'd see multiple rows here with all of your databases listed. But since I don't have any on this account, this is just a blank page pretty much. So in order to get started creating, we're going to go to the top right here in this orange button, and we're going to click on Create Database, which will launch the wizard. So let's just let this load for a moment here. Okay. So straight off the bat, we need to choose a database creation method. So you have two options to pick. The first one is standard create, and the second one is easy create. If you select easy create, it's going to basically use a bunch of defaults for all of the settings. Now, this may be kind of a good idea if you're just starting out and you don't really care about any of the settings, but keep in mind that there could be some pricing implications if you enable certain features that have a pricing cost. Easy create can kind of screw you that way, so just be aware. Since we're going to be doing this via standard create, we're going to be able to specify all of those settings so that we won't have any kind of hidden costs arise a little bit later on. And you're going to get to see all of the different settings that you can pick, and I'm going to explain what they all mean. So added value there. So we're going to go to standard create, and we're going to scroll down now to the engine options section. So this is the section where we choose what type of engine we want to use. So Aurora is the first option here. This is the Aurora engine that is built by Amazon. And we also have options for MySQL, MariaDB, Postgres, Oracle, and SQL Server. Now, a lot of you may be confused. You may be saying to yourself, Daniel, don't we want to use Postgres here? Like, why shouldn't I select this guy here? And that is certainly an option. Keep in mind that if you use Postgres SQL here, you're just using RDS. You're not using Aurora. And I have a great video that kind of runs you through the difference between Postgres and Aurora. It's part of my RDS Aurora versus DynamoDB video. I kind of talk about the difference between Aurora and Postgres. But just a very quick summary of the difference. If you choose Postgres here, you don't get access to all of the value add features that Aurora gives you. I mean, you're still going to get to use Postgres if you pick one or the other, Postgres at the bottom here or Aurora at the top, because Aurora is compatible with Postgres. But if you select Aurora, it's a little bit more expensive, but you get a whole bunch of other value add features such as more read replica auto scaling, failovers without any downtime. There's a whole bunch of extra stuff that you get. So for the minimal cost of a little bit more than what you would pay if you just had a vanilla Postgres SQL instance, I'd say Aurora is definitely a better option. So that's what we're going to pick here. And if I just scroll down a little bit, we can see here there's some more options. So addition. So this is where we get to specify if you want to use MySQL or Postgres. So Aurora is compatible with either or, but you have to pick one or the other. You can't kind of flip-flop between them both. You need to define initially which one you want to use. So since this is a tutorial for Postgres, we're going to click on Postgres here, and a whole bunch of other options become available after clicking Postgres down below. Now, the next option is in terms of capacity type. So you can see here that we have two options. The first mode is provisioned, and the second mode is serverless. So just to briefly summarize this, if you set provisioned, what that essentially means is that you need to worry about the instances that are being used in your database. So you'll be able to select the instance type, you'll be able to select how many read replicas, all the settings around those particular physical machines. If you select serverless, that means that behind the scenes, Aurora is going to provision an instance for you and kind of tear it down when it's not in use and bring it back up when you start querying against that database. Now, there's pros and cons to each of these approaches. I don't want to say like provisioned is better than serverless and serverless is better than provisioned in any way, because you need to kind of do your own due diligence to understand the implications of either. But I think for most people, provisioned is probably the most standard setup that people will use when using Aurora. So that's what we're going to go with in this tutorial. Okay, so let's scroll down a little bit and look at this section here. So engine version. So when you select Aurora, you have the ability to specify a bunch of different versions. So everything from the top one, which is the oldest 9.6.16, all the way to 12.4, which is relatively new. Keep in mind that if you select some of the older versions, you're going to have, so there's a warning here. So you're seeing like that it's going to be deprecated in January 22. So you definitely don't want to use something that's dated. I would use something that's stable, which happens to be, I believe, 12.4 at the time. Also keep in mind that if you select some of these other versions, you may not have access to all of the instance types, which we're going to see in the next section. So I'm just going to leave this on 12.4, which is the most recent as of now, and just leave it at that. So let's scroll down now to the template section and see what's going on there. Okay, so for templates, you can choose from the production setting or the dev/test setting. So by enabling the production setting, it's going to change a bunch of the different settings in many ways that are in the sections below for things like it says it here, high availability, fast, consistent performance. So it may default to a better instance than what you need. I'm just going to put this on dev/test now just to kind of walk you through some of the settings. But if you're setting this up for a production use case, you need to understand these settings anyways. So it doesn't really matter which one you set. It's just going to do some defaults if you set it to production. But let's set it to test for now, just to kind of protect ourselves from any option that we didn't mean to select that's going to have cost implications. And then I'll explain to you kind of like what's going on with each of the settings as we get to them. Okay, so scrolling down now to the settings of the database itself. So there's the database cluster identifier, and you can specify your own name here. So keep in mind that whatever name that you pick here is going to be the kind of parent name, so the name of the cluster itself. And within a cluster, you may have multiple instances, up to 15, I believe, in an Aurora database, or in an Aurora cluster rather. So this is just the cluster name, which is kind of the top level name that you're going to be specifying. Now moving down to credential settings. So we're going to set up a master username. I would suggest not to use Postgres, like change this to something meaningful, because if you expose accidentally your database to like the public internet or someone gains access to it, you don't want to have like defaults here in terms of usernames where someone could just brute force and try to get into your database. So definitely like change this. I'm going to leave it for default just because like that's what the default settings are. But make sure that you change this to something that's unique and meaningful that people can't guess. For password, I'm just going to put in password 123 here. Obviously for your case, you want to pick something meaningful and difficult to guess. And ideally, actually, you probably want to use auto-generate a password. So just kind of keep this in the back of your mind, whatever you selected here for the master username and the password, because we're going to need this when we try to connect to our database in a step that is coming up. So maybe copy that to your clipboard or something like that. So let's move down now to the DB instance classes. So since we're using the provision mode, we need to select the type of instance that we want to use for our database. So as you can see here, it's kind of describing. So choose a database instance class that meets your processing power and memory requirements. The DB instance class options below are limited to those supported by the engine that you selected above. So if you selected, for instance, an older version of Postgres, you may not see like all of these different options here. Like there's a whole bunch of different ones here. Keep in mind the ones at the bottom of this list are super, super expensive. So you definitely don't want to click on stuff towards the bottom of the list unless you absolutely know what you're doing. For most cases, what I suggest to people is just start with the lowest level one and then kind of evaluate your performance with the lowest level one. And if you need to upgrade, you can always change your instance types a little bit later on. You're not kind of locked into this, which is a neat feature of Aurora. It makes it very simple to change instance types, to upgrade, to downgrade, and stuff like that. So keep that in mind when you're selecting your option. You may also want to do a little bit of research in terms of if you want to use memory optimized or burstable classes. Just as a brief summary, burstable gives you kind of baseline performance with the ability to burst to certain levels of CPU utilization, and I believe memory as well. But what's right for you will really depend on kind of what you're trying to do with this database. So I'm just going to leave this as memory optimized for now. And yeah, we'll just put this on R5 large. So I'm going to leave that. I believe that was the default anyway. So let's just leave it all as default. Okay, so the next setting here, Aurora availability and durability. So this is one of the settings where at the top, if you had selected production instead of dev/test as the kind of quick create option, it would have selected this option here, which is to create an Aurora replica. But you can see here that we had this selected as default, don't create an Aurora replica. So just to briefly explain what this setting means, if you have this enabled, what will happen is that Aurora will create a reader node in a different availability zone. And availability zones are basically different logical partitions that may exist in the same data center or a different data center. So what this protects you from is, for instance, say there's like a fire or maybe a flood or some kind of catastrophic event like an earthquake, and it brings down a particular availability zone that your database is hosted in. What Aurora will do, or what AWS will do rather, is detect that scenario and automatically fail over your database to the other availability zone where your standby instance or your replica is located in. So that just gives you extra availability, and that's why Aurora advertises that it has higher availability than something like just RDS Postgres or RDS MySQL, because it has this kind of unique functionality with zero downtime failover. And if you don't want that, keep in mind, like, there's extra costs for doing this. You're going to be basically paying for a node that's in a different AZ, and it's going to be up all the time. But again, it protects you from failures. So if you have a use case that requires your node to be up at all time and you want to be protected from scenarios like this, then go ahead and create that replica. If you don't, then just go ahead and don't create that replica. Again, you can always come back to this and modify it a little later on. So that's it for availability. Let's go down to connectivity now. So when you set up a RDS, Aurora in particular, in this example, any of the options actually, you need to launch them into a VPC. Now, VPC stands for Virtual Private Cloud. It's basically your isolated section of the AWS cloud infrastructure where you are isolated from other customers that are AWS customers, where they cannot access anything that's in your VPC and you cannot access anything that's in their VPC. It's kind of like a little bubble that you put all your stuff into, and no one could get in or out of your bubble unless you kind of mess with the options or you give them permission. So we need to launch it into a VPC. Now, you may say to yourself, like, I've never created a VPC when I created my account. And that's because AWS gives you a default VPC that you can see here. It's just labeled as default. And in the past, I was just doing some demos. So you can see here I have a second one. It should auto select your default VPC. And by default, the default VPC has a bunch of very liberal options that don't really block you, that have sensible defaults that allow you to do things like make outbound requests to the public internet if you have something that's in your VPC. So sensible stuff. So we're going to leave this selected as the default VPC, but keep in mind, if you have a different VPC that maybe your EC2s are located in, then you want to launch it into that same VPC as well. Now, keep in mind that after you launch it into the VPC, they do give you this warning so that after a database is created, you can't change the VPC selection. So effectively, your database is going to be stuck in that VPC, and copying it over to a different one may be challenging. So keep this in mind when you're selecting and just kind of try to put it in the right place. Subnet group, so which subnet group that you want it in. I'm not going to really go into this too much. This is more into the specifics of VPCs. But the setting that we do want to touch and talk about briefly is the public access. And you can see here, we have a default selected to no. So RDS will not assign a public IP address to this database. Only EC2 instances and devices inside the VPC can connect to your database. Now, for most use cases, you want to keep this as no, because you don't want to expose your database to the public internet. You don't want to give it a public IP that people can potentially try and access it from. Now, since this is a demo, I'm going to leave this as yes so that we can access it from pgAdmin from like my local machine, which is obviously not in the AWS VPC. So that's going to give it public access, but you do want to ensure that if you're launching this for any kind of production use case, you kind of come back and redo this and set this as no so that you can kind of lock down your instance so it's not accessible by anyone else. So we're going to leave this as yes for now, and keeping on scrolling down. So this is an option that we're going to kind of need to modify a little bit later, which is the security group. The security group, essentially, you need to associate it with your RDS Aurora database. And the security group is kind of like a firewall that says which traffic is allowed in or out. And you can specify it all the way down to the port and protocol level. Now, by default, your VPC is going to block all incoming traffic from the public internet. And when we are trying to access our instance from, my machine through pgAdmin, we're going to put in like the database string later. By default, it's going to be blocked. And so you'll see when I try to set it up, initially it's not going to work. We're not going to be able to connect. And then I'm going to go and modify the security group that this instance is associated with to allow incoming connections from the internet. And then you're going to see it's going to work straight out of the gate. So we're going to leave this as default for now and come back to this a little bit later once I kind of demonstrate that in the pgAdmin section. Now for availability zone, this doesn't really matter. You can pick whichever one you want here. There's no really need to kind of nickel and dime over which one you select. They're pretty much all the same. For additional configuration now, if you want to put this database on a different port, you can go ahead and do so. I don't really see any reason that you would want to do that, but they do give you that option to make that change. Now, in terms of database authentication, you have two additional options here. So IAM database authentication and Kerberos authentication, which uses Microsoft Active Directory. Keep in mind that we're always going to have password authentication on. So this is like in addition to password authentication. So I'm just going to leave these as default off for now. But IAM database authentication is really handy. It lets you control access to your database through IAM users and IAM policies and stuff like that, which is super, super handy instead of just like creating a username for everybody. And that gets unscalable and unmanageable after a certain point. So I would look into this if you have time, but for this demo, we're not going to do that. So we're just going to kind of keep on moving. So additional stuff, so additional configuration. These are more advanced settings, and I do want to touch on some of this stuff a little bit. So I'm just going to talk about the stuff that you need to know about, generally speaking. I'm not going to talk about everything here. So you can create an initial database name. I'm just going to leave this as default because I'm going to create my database via pgAdmin a little bit later on. DB cluster parameter groups, these allow you to essentially create kind of configuration templates and apply them to like all the databases that are in this cluster. So you can create your own through a different kind of setting or wizard in the RDS console. And then anything that launches into this cluster will have these settings that are specified through this template. So keep that in mind. It's a little bit useful, but I haven't used it too much in the past. Failover priority, again, a more advanced feature. This allows you to assign different tiers to your read replicas so that when your primary goes down, you can fail over to a particular tier of your read replicas. So, if you have some kind of preference in terms of which ones it will fail over to, you can attach that instance to the associated tier and then select which option you want them to fail over to first. So I'm just going to leave this as no preference as it doesn't matter for this example. Okay, so moving down to backup now. So backup retention period. So as we can see here, this chooses the number of days that RDS should retain automatic backups for this instance. So by default, it's 7 days, and you can go all the way up to 30, I believe. Oh, 35 now. Oops, sorry about that. You can specify like how long you want your backups to stick around. I would say 7 days is more than plenty. If something goes wrong and you haven't noticed in 7 days, then you probably have a larger problem, or you're probably lacking alarms in some capacity. So this is fine for our kind of just demo purpose. You can even probably lower this to 1. So copy text to snapshots, that doesn't matter. Encryption, we're going to leave that as on. What else do you care about here? Performance insights. So this is a kind of useful setting that helps you root cause issues in terms of database performance, or maybe certain queries are a little bit slower and you're trying to figure out why. This could be a setting that's useful for you to diagnose those kinds of use cases. Keep in mind there's extra cost for this. So I'm not sure if like by default it's on, since I had to expand out the additional configuration options. But I'm going to disable it because I don't want to be building anything more than I have to. And, you can take a look at what the pricing model is here. I believe it's on the vCPU level. And so it varies depending on like stuff like your instance type and a whole bunch of other factors like how much you use it, stuff like that. So if you're interested in that, you can enable it and kind of do some more research to experiment, but I'm just going to disable it for now. We also have another option here, so enhanced monitoring. So the default, I believe, is 5-minute granularity. And if you want, you can get more granular data sets. And I believe it goes down to 1 second. So that's very, very fine grain monitoring. So stuff like CPU utilization, memory utilization, disk space, like stuff like that. Those are the kind of metrics that this is talking about. And they have some more details here. So threads as well. Now keep in mind that for like the lower you select this, the more number of data events that are going to be sent to CloudWatch, and therefore the more expensive it's going to be. So there is additional cost for this. It's not just kind of free lunch. You get to have the best and not pay extra. So just keep that in mind. So I would suggest to only really set this if you absolutely need very, very fine grain configuration or very, very fine grain monitoring. But you can also come back to this a little bit later on after you created the database to modify it and activate it if there's something in particular that you're trying to debug. But for this example, we don't need that, so I'm just going to leave that as default. Going down now to the maintenance section. So it's just asking us if we want auto minor version upgrades to just happen by default. I'm just going to leave that on. It's probably a fine choice. But if you want to make sure that your database is never doing something behind the scenes in terms of version upgrades or patching or anything like that, then you can just disable this. Disable, there we go. But for my use case, there's no real impact. Maintenance window, you can also specify when Aurora does its maintenance. So you can specify like the time of day. If you want this to happen, for example, at 1 a.m. or midnight when people aren't really using your database or you don't really have many other customers at that time, that's probably a wise choice. So if you select no preference, it'll just kind of make its best decision or do it whenever it wants. But it's probably a better idea to specify when you want this to occur because everyone's traffic patterns are different. So for me, I don't really care since this is a demo, so we're leaving that no preference. For deletion protection, you want to make sure this is off where it comes as default. If you're just setting this up as a test, if this is a production use case, you want to have this on. This is going to make it so that you can't delete it unless you remove deletion protection, which is kind of a pain in the rear end to kind of navigate how to delete your database when you have this thing on. So that's pretty much it in terms of all the settings. We're going to go ahead now and click on the orange button here to create the database. And often this takes a few minutes, but it should bring us to the next screen pretty quickly. And so we can see here, if I just zoom out a little bit to see like all of the options at once, we can see here, this is our database cluster identifier. So that's database-1. And we only launched one instance into our database cluster, and it's just giving us the name instance1 appended to the cluster name. So you can see here over on the right, it says creating. So it's creating two things now. It's creating the cluster itself, which is database-1, and it's also bringing up that instance, which is instance1 that's a DB-R5 large instance type. So this will take, I would say, like anywhere between 5 and 7 minutes to create all this stuff from scratch. And it also depends if you have like replicas created as well as part of your initial configuration. But I'm just going to come back in a few moments here. Hopefully this will say available in like 5 minutes or so. And I'll just fast forward and let you know when it's all done. All right, guys, so it's been about 10 minutes and we can see now that the status is set to available for both the cluster and the database instance as well. So we're basically ready to go. So in order to get our instance endpoint that we can connect to from pgAdmin, we click on the instance here and we see here that our endpoint is this guy here. So I'm just going to copy this. I'm going to put it to my clipboard because we're going to need it a little bit later. And also notes that we are on port 5432, which is just the default for Postgres. So what we need to do now is launch up pgAdmin. So if you've never done that, you can go ahead and download it from this website here, pgadmin.org/download. A whole bunch of different options here. I downloaded the one for Windows, so I have the application installed on my machine. Also works for Mac, and they also have a Docker container that you can use if you don't want to actually install anything on your machine. So go ahead and download that, install it, and launch it. And after you do, you'll see basically this screen, which is just the default view of pgAdmin. So in order to get started, what we need to do is go ahead and click on Add a New Server. And here it's going to ask us some details. So like, what do we want to name this thing? I'm just going to name this actually Aurora Demo, I should say. And leave all this stuff as default. And in terms of connection, this is where we need to specify that query string that we just got, which is what I just created. And we're going to leave this on the default port, which is 5432. All this stuff can stay the same. So here it's asking us for our username and password. So if you change your username, make sure you go ahead and change that. Our password for this demo was just password123. So that's what I put in there. And so I'm going to click on save now, and it's probably going to do a connection prompt thing or try to connect to the database. And you'll see that it should not work initially. Okay, so this is just setting the default password for pgAdmin. Put whatever you want there. This is just part of the software. So clicking on save again, and it's trying to establish now, like, can I connect to this database? Is the connection working correctly? Eventually we'll probably see a timeout, and there it is, timeout expired. And that is because of an issue with our security group. So what we need to do now is go back into our AWS console and modify the security group that is associated with our database. So I'm going back into the console now, and let's just start from scratch. So we're going back to databases. And so we're going to select on the database instance of the writer. So go ahead and click on that guy. And you can see in this default screen for connectivity and security, this is where we grabbed our endpoint from previously. Now over here on the right where it says under security, VPC security groups. So this is the security group that's associated with this instance. So we need to go ahead and click on this guy. I'm actually going to do that in a new tab so we can come back here later. And we are going to mess with the options here. So this brings us to the VPC section of the AWS console. You can get here by just going to VPC and going to security groups. And here's the option that you need to select here on the side under network and security, and then you just click on security groups. So I'll just click on back now. So this is the security group that we have associated with our RDS instance. So I'm gonna go, you see this bottom section here, it's a little bit small. We need to mess with the inbound rules. So I'm just gonna click on this little icon here to make it a little bit bigger so we can see everything. So what we need to do now is to go to inbound rules. So we're going to go ahead to the right here under edit inbound rules, and it's going to bring up this wizard thing. So under type where it says all traffic, we want to find the Postgres version. Here we go. So Postgres SQL. And that's TCP on 5432. Alternatively, like you can do all traffic here if you want, like, or custom TCP and set it to 5432 or all TCP. But the goal is usually to do like the least privilege model. So give away as few permissions as possible that you require for what you're trying to do. Okay, so the next step is to specify the rules for the security group in terms of what incoming connections that we want to allow. So I'm just going to click on this section here, and it's going to give us some pop-ups. So essentially what we want to do here is allow incoming connection requests from anywhere on the internet. And the way that you specify that is by using this CIDR block notation here. So 0000/0. That's going to give us incoming connections for IPv4. We also need to do the same thing for IPv6, which is this option here, which looks a little bit different. It's ::/0. So that'll give us connectivity from incoming connections from the public internet. So I'm going to go ahead and click on Save Rules in the bottom right. Now, if you take a look at the bottom here, we have these new inbound rules that are associated with the security group, and it's allowing IPv4 and IPv6 internet access into our security group that's associated with this Aurora instance. So if we go back now and go back to pgAdmin and just try this again, go ahead and click on Save, we see here, this was instant. So it was able to connect right away. So that was how we can bypass that problem. Keep in mind, you don't want to have public internet access for this thing in a production use case. You want to have it in a private subnet and do all the right security things. But this is just a demonstration to help you understand how it works. So now we are connected to our Aurora database that exists on AWS. So if we expand databases here, yeah, you can see all like what's going on this database in terms of sessions, in terms of TPS or transactions per second, in terms of performance. So it gives you a good bunch of details. You can go ahead on the right-hand side here and just expand this out. So Postgres, I believe it's under schemas and under public and underscore tables. So we don't have any tables that exist here. That's why this is empty, but you can very easily create a new table here if you want, and call it foobar and put all your input parameters here as well. So, this is how you set up a Postgres instance on Aurora. I hope you enjoyed this video. If you did, be sure to check out my other ones on Aurora and RDS on the side. And don't forget to like and subscribe. Thanks so much, folks, and I'll see you next time.